There's a telescope floating 1,000,000 miles from Earth, colder than almost anything in the known universe, and it was built to answer one quiet question: where did we come from? For 4 years it has been sending images home. Beautiful images, award-winning images. But somewhere inside that flood of data, the James Webb Space Telescope captured something that its own scientists did not want to find. Not a monster, not an alien fleet, something far more disturbing. A pattern that suggests the story we've been told about the universe may be wrong. And the deeper astronomers look, the worse it gets. So the real question isn't what Webb saw, it's why nobody warned you. Let me start where the cracks first appeared, because you need to understand something before any of this makes sense. The James Webb Space Telescope was never designed to shock us. It was designed to confirm us. For 100 years, physicists have built a single, elegant model of how the cosmos works, how it exploded into being, how gas cooled into stars, how stars gathered into galaxies over billions of patient years. That model even has a name, one you've probably never heard spoken aloud: Lambda CDM. It is the operating system of modern cosmology. Almost everything we believe about the age, the size, and the destiny of the universe runs on it. And Webb was supposed to be the machine that finally proved it right, once and for all, by peering back to the very beginning of time. But that is not what happened. That is the opposite of what happened. Because when Webb turned its enormous golden eye toward the earliest moments of the universe, to a time just a few 100,000,000 years after the Big Bang, when there should have been almost nothing out there but faint smudges of newborn gas, it found galaxies. Not faint ones, not small ones. Enormous, structured, blazing galaxies that had no business existing yet. Astronomers began calling them the impossible galaxies, and the name was not a joke. According to the Standard Model, galaxies of that size need billions of years to assemble. Webb was seeing them fully formed when the universe was barely a toddler. Read that again, because the implication is staggering. Something built these giants far too fast, using a recipe our physics cannot yet explain. At first, the scientific community did what scientists always do when reality misbehaves. They looked for a mistake. Maybe the distances were wrong. Maybe the brightness was being misread. Maybe these galaxies only looked massive because of some trick of the light. And for a while, that hope held. But then the follow-up observations arrived, and the follow-ups after those, and the problem didn't shrink. It grew. Team after team, using different instruments and different methods, kept confirming the same unsettling truth. The early universe was not the quiet, empty nursery we had imagined. It was already crowded. It was already violent. And it was already old before it had any right to be. Now here's where it stops being an interesting anomaly and starts becoming a genuine crisis. In early 2026, a team at Texas A&M University pointed Webb at a region so far away that its light has traveled for over 13 billion years to reach us. We are, quite literally, looking at the universe as it existed only 800 million years after everything began. And in that impossibly young cosmos, they didn't find one lonely galaxy drifting through the dark. They found 5 galaxies crashing into each other at once. A colossal collision, a pileup of entire star systems, in an era when collisions like this were supposed to be almost unheard of. The model said early galaxies should be small, isolated, and simple, bumping into each other, maybe 2 or 3 at a time if they were unlucky. Webb showed 5 of them merging in a single, tangled, glowing knot, forming stars at roughly 250 times the rate of a normal galaxy. Think about what that actually means. The gentle, gradual, orderly universe described in every textbook was, at its very birth, a place of chaos and speed and impossible density. And the collision wasn't even the strangest part. Wrapped around those 5 colliding galaxies, the astronomers detected a vast halo of glowing gas. And that gas was rich in oxygen. Oxygen doesn't just appear. It is forged inside the cores of stars and then flung out into space, a process that scientists believe took vast stretches of cosmic time to spread across a region. Yet here it was, already scattered through the void, in a universe that had barely started. The lead researcher put it plainly: our theories of how galaxies assemble and how fast they do it need to be updated to match reality. That is a polite, professional way of saying something much heavier. It means the map was wrong. And if you think that's where the ground stops shifting beneath our feet, you don't yet understand how deep this goes, because the galaxies were only the beginning. The real horror, the thing that genuinely keeps some cosmologists awake, is what Webb found hiding at the center of them. Black holes, monstrous ones, appearing far too early and far too large in a cosmos that should have needed eons to grow them. In the standard story, black holes are supposed to build up slowly. A star dies, collapses, and leaves behind a dense remnant. Over immense periods of time, that remnant feeds, swallowing gas and merging with others until, after billions of years, it can bloat into the supermassive giants we see anchoring galaxies today, including the one at the heart of our own Milky Way. That is the timeline. That is the rule. Webb broke it. Deep in the early universe, in a tiny galaxy more than 13 billion light-years away known by the cold catalog name Abel 2744 QSO1, astronomers mapped the swirling gas around a central black hole and calculated its mass. It weighed roughly 50 million times as much as our sun. In a universe that young. And then came the sentence that should have been front-page news everywhere and somehow wasn't. The researchers concluded that this black hole likely predates the galaxy around it, that it may have formed within the first second of the Big Bang itself, and that it must have been enormous from the very start. Sit with that for a moment, because it inverts everything. We have always assumed galaxies come first and their black holes grow up inside them like a pearl forming slowly inside an oyster. Webb is now whispering the terrifying alternative, that in some cases the black hole came first, that the monster was there before the house was built around it, that the seeds of the largest, most destructive objects in existence were planted in the opening instant of creation, before there were any stars, before there was any structure, before there was anything at all. And nobody can yet explain how. Now, let me pull back for a second, because I want to be honest with you about something, and this honesty is exactly what makes the story more chilling, not less. None of these discoveries came with sirens. There was no emergency broadcast. There was no press conference where a stunned official stepped up to a microphone. Instead, each of these findings arrived quietly, buried in dense academic papers with titles designed to make your eyes glaze over, phrases like atmospheric asymmetries and slow-rotating galaxy in the early universe. That is where the real drama lives. Not in a lie, but in a language so technical that the average person will never realize a revolution is unfolding inside it. What most people are not seeing is that the very foundation of modern cosmology is quietly being renegotiated, paper by paper, and almost no one outside the field has been told. And here is the part that turns unease into something colder. This isn't one rogue result that can be dismissed and forgotten. It is a pattern. A galaxy that should be spinning, but isn't. Discovered in 2026, a massive galaxy from less than 2 billion years after the Big Bang was found to have no rotation at all, a stillness normally seen only in ancient, dead galaxies near us, not in the roaring youth of the cosmos. A galaxy that formed all its stars and then simply switched off far too early. Every one of these findings, on its own, could be explained away with enough effort and enough excuses. But together, they point in the same direction, like a dozen compasses all trembling toward the same invisible force. And that direction is uncomfortable. It suggests that the early universe operated by rules we have not discovered yet. So the question naturally becomes, what force could possibly build giants that fast? And this is where the story bends toward something even more unsettling, because the leading suspects are things we've never actually seen. Some scientists believe the answer lies with dark matter, the invisible substance that supposedly makes up most of the mass in the universe, a thing we have inferred but never directly touched. Perhaps dark matter behaved differently in the beginning, clumping harder and faster than our models allow, pulling gas together with a violence we've underestimated. Others suspect the problem is even deeper, that our understanding of how the very first stars ignited is simply incomplete. And a small, quieter group wonders whether the timeline itself, the age of the universe, the rate of its expansion, might contain an error we have not yet caught. Any one of those answers would rewrite the textbooks. And right now, astronomers cannot rule out any of them. But while the cosmologists were wrestling with the birth of the universe, Webb was pointed at something much closer to home and much closer to the heart. Because there is another question this telescope was built to chase, a question older and more personal than any equation. Are we alone? And on this front, Webb delivered something that has fractured the scientific community into open argument, a discovery so delicate and so loaded that even the people who found it are afraid to say what it might mean. The target was a world called K2-18b, a planet orbiting a small red star roughly 124 light-years away. It is not like Earth. It is far larger, wrapped in a thick hydrogen atmosphere, and some scientists believe it may hide a single planet-wide ocean beneath that sky, a so-called Hycean world, part water, part gas, unlike anything in our own solar system. Webb studied the starlight filtering through that alien atmosphere, reading the chemical fingerprints written into the light. And what it detected sent a shock through the astrobiology community. Methane, carbon dioxide. And then, faintly, controversially, a hint of something else, a molecule called dimethyl sulfide. On Earth, that molecule has one dominant source and only one, life. Specifically, marine phytoplankton, the tiny living organisms drifting through our oceans. It is, quite simply, one of the strongest chemical fingerprints of biology we know how to look for. Now, before your imagination runs to alien oceans teeming with creatures, let me tell you why this story is a masterclass in scientific tension. Because the truth here is more gripping than any easy answer. When the team first announced the possible detection, the world's headlines exploded. Signs of life, a biosignature, the discovery of the century. But the actual data was maddeningly thin. In science, a detection is measured in sigma, a scale of statistical confidence. To claim a real discovery, you need to reach 5 sigma, the gold standard, meaning the odds of the signal being a fluke are astronomically small. The dimethyl sulfide signal from K2-18b did not reach 5 sigma. It didn't even reach 4. At its strongest, in later mid-infrared observations, it hovered around 3 sigma, tantalizing, suggestive, and nowhere near proof. And then came the reckoning. Because that is how real science works. It attacks its own most exciting claims. Independent teams took the same data and ran it through their own methods, and one after another, they came back with a colder verdict. Some found no statistically significant evidence for the molecule at all. Others pointed out that dimethyl sulfide has since been detected in comets and in the cold clouds of interstellar space, places where there is no life whatsoever, which means the molecule is not the airtight signature of biology we once assumed. Still others argued that the signal could be an illusion, a chemical mirage created when the fingerprints of ordinary methane overlap and masquerade as something more exotic. The dream did not die. But it did not survive intact either. It entered a strange limbo, neither confirmed nor destroyed, where it still lives today. And this is the part that should genuinely unsettle you, because it reveals how close we are standing to an answer we may not be ready for. The question of whether K2-18b harbors life has not been closed. It has been suspended. The signal is too weak to celebrate and too persistent to dismiss. The scientists themselves have said that with just another 16 to 24 hours of Webb's observing time, they might be able to push the measurement toward certainty, one way or the other. Which means that at this very moment, floating in the dark, a machine we built has captured a whisper that might be the exhaust of an alien biosphere, and the only thing standing between us and knowing is a cue for telescope time. The most important question in human history may be answered not by a dramatic discovery, but by a scheduling decision. Now step back and look at the shape of all of this together, because the pattern is the real story. On one side, Webb is telling us that the universe was born faster, denser, and stranger than we ever believed, with galaxies and black holes appearing in defiance of the physics we trusted. On the other side, it is telling us that the ingredients, and possibly the fingerprints, of life may be scattered across worlds we can barely see. And connecting both of these threads is a single, quiet, frightening realization. The models we built to explain our place in the cosmos are cracking under the weight of real data. Not because scientists were foolish, but because for the first time, we finally have an instrument powerful enough to see how much we got wrong. This is not a failure of science. Understand that clearly. This is science working exactly as it should. A machine so precise that it can embarrass its own creators, forcing them to admit that the universe is deeper than their equations. But it is also a profound loss of certainty. For a century, we believed we understood the broad outline of everything, how the cosmos began, how it grew, and roughly where we stood within it. Webb has quietly dissolved that comfort. The early universe is a mystery again. The origin of the largest black holes is a mystery again. And the question of whether we are alone is no longer a matter of philosophy. It is now a matter of engineering, of data, of a signal we are one measurement away from confirming or crushing. And that brings us to the most uncomfortable truth of all, the one that connects the impossible galaxies to the ocean world orbiting a distant red star. Every single one of these discoveries points to the same conclusion. We do not understand the universe nearly as well as we told ourselves we did. The telescope we launched to confirm our story instead handed us a new one, half-written, full of contradictions, with the ending torn off. And there is more coming. Webb is still up there, still watching, still colder than ice, still peering into places human eyes were never meant to reach. Somewhere in its next batch of data that already exists, that is already flowing back to Earth right now, there may be an image that finally breaks the model completely, or one that confirms, beyond argument, that something is alive out there. So here's what I want to leave you with. The scientists studying this data are not celebrating. They are nervous, they are rewriting, they're quietly admitting to each other that the picture no longer fits the frame, and the rest of us have barely been told. What happens when the next observation of K2-18b comes in and the signal either vanishes or sharpens into certainty? What happens when Webb finds a black hole even older, even larger, even more impossible than the last? And what happens to us, to how we see ourselves, to the story we tell about our place in all of this? The day the machine we built finally shows us something we truly cannot explain away. Because that day is not a fantasy. Judging by everything Webb has already found, that day is not a matter of if. It is only a matter of when. And when it arrives, the question will no longer be what James Webb detected. The question will be whether we were ever ready to look.